This is the HL4 from the 45Drives 45 Home Lab division, and TLDR, this is a crazy awesome little device, and TLDR2, I'm taking 3 of them and making them my new cluster for highly available services and Ceph storage. Right off the bat, let's take a look at this bad boy. As you can probably tell from the name, the HL4 is designed to hold 4 hard drives using a toolless, friction-based system like their other chassis. But there's more to this little device if we keep looking. Outside of the crazy sturdy cold-rolled steel, 45Drives built this awesome hinge mechanism to where you can get basic access to the inside from one side, then the second hinge lets you unroll the whole device without disconnecting anything. I'll be honest, I've never really seen anything like this in a small ITX build. Which brings up my next point. It's an ITX build which has its pros and cons. Pros, it's compact. Cons, less expansion options. But we have a little trick up our sleeves. You can buy the chassis by itself for just under $600, which is expensive. No getting around that. I'm not even going to try to pretend to act like this is a consideration for your budget server build. I mean, it's just not. But that's just on brand for 45Drives. They make high quality stuff and that costs a premium. There are 2 other options, one with the chassis and power supply and another with a fully built system inside at $768 and $1,318 respectively. So what I have here is the full build, which gives us a Gigabyte B550i motherboard, an 8-core Ryzen 5700G, 64 gigs of RAM, and a 500 gigabyte NVMe drive. Now there are plenty of combinations of motherboards and CPUs you could have gone with from different chipsets and generations, but this specific combination has a very important feature. That feature is the ability to do PCI bifurcation on the single X16 slot at X8, X4, X4. Now why is this important? Well, it lets me use one of these. So this little PCIe adapter lets me take a single X16 slot and breaks it out into 2 NVMe slots and another physical X16 slot that are wired at X8. The other cool thing is that the size is designed so that if you use it with a half-height PCIe card, it'll fit up perfectly in a standard PCIe slot, but that didn't stop us from running into an issue. You'll see in a bit. Now, obviously, you don't have to use one of these, and if you have a single slot PCIe card you want to use, then go with that, but I wanted to get the most out of it. I'm going to go with 2 128 gigabyte NVMe drives and a Connect X4 dual port 25 gig card. The goal here is to use the dual NVMe drives as a mirrored boot device for Proxmox, and a 25 gig card will give us an overkill amount of bandwidth for Ceph and external data transfers. As for the spinning storage, we're going to go with 3 4 terabyte drives, which isn't going to give us any big drive energy, but with 9 total of them across 3 systems, we're looking at 36 terabytes of raw storage. Not bad depending on your use case. My use case for this is to have an H8 Docker setup, a test K3s cluster, and a decent size array to learn Ceph on. As for that last slot, I'm going to throw in a 500 gigabyte SSD just to give myself the opportunity to mess with some tiered storage in Ceph. Now, I already built out the other 2 systems and installed Proxmox, so I know we're about to run into a little issue here when we install this card, with no fault of the HL4, mind you, so you'll see. So the Connect X4 is clearly a half-height card, which is great, but it's not designed to sit at the far side from the motherboard. And what do I mean by that? Well, when you look at the full height version, you'll see that the ports sit closer to the motherboard, which allow it to easily slot in. However, when it sits further away, it doesn't have the clearance to easily fit in due to the ports extending out. This does require a bit of elbow grease to get in, but they eventually get in there. So overall thoughts on the HL4, I mean, it's legit a really cool little device, but boy, is it expensive. I mean, it's built like a tank, and the attention to detail with the hinge mechanism, the hard drive backplane, cable management, and acrylic side panel are top notch. Does all this justify the price? For you, probably not, but for you over there, maybe. Anyway, we have to get this last one set up and ready for our cluster, so let's do that. I'll meet you at the software side. So like I mentioned, I am going with Proxmox, and I did use those 2 128 gig NVMe drives as mirrored boot drives, so if one fails, we're still good to go. Another thing to note is that the motherboard has 2.5 gig networking on it, but I'm not using that because I have 2 whole 25 gig ports, which should be enough bandwidth. Now, before going in and doing all the clustering stuff, I did some configuration on each of the nodes. So the main one being to go in, disable the enterprise repos, add the free ones, the no subscription one, and do an update. Another thing was setting that 500 gigabyte NVMe drive as its own LVM thin pool on each of the devices, just so that it have some local storage on each of them, but you can do whatever you want with this. The last couple of things I'll show you on here since I haven't done them on the last server. So one of them being set up the other 25 gig NIC. So the original one is being used by Proxmox, so it's already set up. But we want the other one to be used as the Ceph backend. So we're going to go into here, into networking, and we are just going to create another bridge using that other interface. And since we're already using the ENP1 0 and 0, we are going to use the other one, which is ENP1S0F1 NP1. And we don't have to do VLAN aware. I'm going to show you why really quickly. So create that, apply configuration. And so the setup I'm actually running is if we go over into our unified network, you'll see that all of my main 25 gig connections are up here to each of my systems. If we look at each of them, you'll see we have 92, 93, and 91. But down here, since we want our Ceph network in its own contained VLAN, you can see I've set the native VLAN to this Ceph network, which is just a VLAN I created. Each of those has the same configuration. They are all within that Ceph network. So since this is the native VLAN sent, we don't have to have the bridge network VLAN aware. If you didn't set this, you could set it VLAN aware and set it to 90 if you want, but this I think is just easier. Also, one more thing on the network side is within here, under my Ceph network, I set it as the isolate network option, meaning that devices within this network can talk to each other, but they can't get out, which is what we want on a Ceph backend network. You can do this on your own in the firewall rules, but this one-click option just makes it easy. Okay, so all of our setups should relatively be the same for the most part. And obviously we want to go in and check our disks to make sure they're all there. And you can see, yep, 4 terabytes in our 500 gig SSD, 4 terabytes in a 500 gig SSD. And on my first one, Alvin, you'll actually notice that I made a mistake. We do have our 4 terabytes, but I accidentally put a 1 terabyte SSD in there, and it is apparently 38% wear out. So I probably should replace this, but since this is going to be a test Ceph system, maybe we'll just leave it in there and see what happens when it eventually kicks the bucket. So at this point, we are good to go and ready to set this up as a cluster. So I'm going to do it starting on my main system, or my first system, which is my Alvin device. So to create our cluster, we go into Data Center, down in the cluster, and then click, yep, you guessed it, Create Cluster. You have to give it a name. We'll do HL4 Boys, and the cluster network is going to be our main one. Click Create. It's literally done. Then the next step to join our other 2 nodes to the cluster is go to Join Information here. You're going to see a bunch of stuff here. All you have to do is click Copy Information. Then go to our next system, again into Data Center, Cluster, Join Cluster, Paste. Now it's going to ask for our root address to the main system. I set these up with the same password. You can do it however you want. We're also going to add this node's IP address to the cluster network as well, just so that we have more options to get in. Then we go into our next node, Data Center, Cluster, this time Join Cluster. And we are going to paste that information. We're going to enter the password for our node and join. Not found on local node. Local node address cannot use a... Oh. Click Join, requesting addition. Gonna let it do its thing. And it may time out here and give you an error because it's doing its thing on the cluster. If we go back to that one, you'll see that it's actually been added down here, which is nice. So there it is. We have Alvin and Simon. So if I try to enter again on this IP address, which is 92, we should still be able to get into the cluster from both 91 and 92. And it looks like we can. Awesome. And again, we just do the same thing on the last node, join cluster, password, IP, join. We have all of our nodes in the cluster, and for some reason, it got rid of my NVMe single on each of these, so I may just have to add that back. Probably wait to do that until after you create the cluster, because what I'm guessing happened is that it's linked to a host name, and since they're part of the cluster, the host name is modified now, or something weird's going on with that. Yeah. I'll figure it out though. I guess that's what happens when you do this on the fly. But now, for the fun part, let's create our Ceph instance. So now we have a cluster. We can go into Data Center, go to Ceph, and install Ceph. It's going to ask us which version. I think Reef is the newest. There's actually Squid out. Yeah, I think we're good on Squid. Let's just do Squid, yellow. All right, Squid, repo, no subscription, and start the install. And after that, it's going to ask you for some configuration. So here you're going to set the two networks within Ceph, your public and then your cluster network. So basically what's used for the outside world access and what's just used within the cluster. So public, we're going to set that to our local one. And cluster network, we are going to leave alone for a second. So right now it's going to be set to the same, but we'll deal with that. So what we should have done was we should have gone into network here and statically set the IP address we wanted here. So we're going to do an address that's part of our Ceph network, which is 192.168.90. And we'll just keep this one consistent with the node. So .91 and it's -24. And we don't need a gateway. And hit OK, apply configuration, yes. So to install Ceph, you have to go on each node and actually install Ceph. By going down here to Ceph, it's going to prompt you to install it. Yes. Now we have to make that change to our cluster network by modifying the configuration file, which is located in etc pve ceph.config. So down here, we are going to change the cluster network to 192.168.90.91 and a 24 subnet. The next thing we are going to want to do is add more monitors. So depending on the size of your cluster, if you have, dozens of nodes in a large deployment, you may want to specify certain ones as monitors, but we have the smallest one possible with 3 nodes. We're just going to make them all monitors. So let's go ahead and create one, host, our second one, Simon, create, and the same thing with Theodore. And as with monitors, it's going to be the same thing with managers. We're going to make the other 2 managers as well. All right. So next up is to create our OSDs or our disks. So let's go ahead and get all of those set up. So in each node, we'll have those 4 disks that we wanted to use. So let's just create them. You could probably set this to auto detect the device class, but I want to manually set them just because I'm actually going to use this in a bit. And I'm just going to do this for all 12 disks. All right, here we are with all 12 of our OSDs created with the class accurately set for each of these disks. And the next thing we want to do is to utilize that class and create something called a crush rule, which essentially lets us take specific pools that we're going to want to create and assign them to a class. So if we want a pool that just writes to our SSDs, we can assign that to the crush rule that only writes to the SSDs. And if we want one for mass storage, we'll have the same thing with the HDDs. So we are actually going to have to do this from the CLI. Sorry. Okay, hit Ceph just to make sure we're in. We are. And we're going to do OSD crush rule create replicated. Then we're going to give it a name. We'll call this one SSD. The root, which is just set to default. The failure domain, which you'll just set as host. And then the class, which is SSD. And we are going to do the same thing for the hard drives. And now we're going to go back into our Ceph. And we see we have a warning here. One OSD is experiencing slow operations. OSD.3. I'm betting it's that 1 terabyte almost dead SSD. Let's see. Yep. All right. Well, we'll just see what happens. So we are going to create our pools. So go into pools, go to create. And this one, we will name this Ceph Fast. And the size is going to be how many replicas you want of this. We can only do 3 because that's the max. This is actually the base configuration. So this is the minimum that you can do on a Ceph cluster. I'm going to leave our minimum size to 2. We're going to leave the number of PGs to 128. We're going to leave auto scaling on. And the thing we're going to change here is our crush rule, which we want to set this one to SSDs and hit create. And you'll see when we did that, it actually created that storage on each of our nodes to use. Since this is shared across the cluster through Ceph, we can now access this same storage from any node meaning that we have highly available storage for all of our nodes, and we are going to do the same thing, but with our hard drives. So we're going to create Ceph big, same thing, change this to our HDD crush rule, leave everything as is, and hit create. And now if we go in here, you'll see how much storage we actually have to use on each of those pools. So you can see here, since we are using that SSD crush map, we have 633 gigs of total space to use based on how many replications and the minimum replications we had set. And if we go into Ceph big, we have 11.4 terabytes of usable space, which makes sense because we have a total of 36 terabytes, but we need 3 replications. So do that division and some formatting, you get 11.4. So had we had another node or 2 or 3 more with the same replications, this number would be higher. But again, this is the minimum specification that you need for Ceph. So this is what we get. And at this point, we are free to do whatever we want with some highly available storage. So go ahead and do whatever you would on your normal Proxmox system with the security in mind of knowing that you have a highly available system. So the first thing I'm going to do, and probably the only thing for this video because I actually have some plans to do a bit more in-depth stuff in the future, I want to set up a Docker virtual machine that will be set to HA mode, meaning that if one node goes down, that VM can just easily be automatically pushed to a new node as if nothing happened and have all of its configuration, all of its data safe and secure within Ceph. So here I have a Docker virtual machine. All it is Ubuntu server VM. You can set this up with any type of virtual machine you want or container. The only thing you'll want to make sure is that when you set up your storage, that is tied directly into the cluster storage. So you can see here, I used my Ceph fast pool. And, we have 2 of them, but I wanted the OS boot disk on the fast one. So just make sure it's on that, and you can migrate this. So I can go to migrate and select another node manually if I want to. This is only saying can't migrate VM with local CD, but I've already removed that here, so ignore that. But if we want this to happen automatically, what we're going to have to do is go into HA down here, and we're going to add a resource. Then we only have 1 VM. We're going to add this Docker VM. It's going to ask for max restarts or max relocations. I'm just going to set it to 1. That should be fine unless we have a major catastrophe. And it's going to ask for group. We don't have one yet. And then just click add. And that's literally it. I mean, it is set to HA mode now, so if Alvin goes down, this will be migrated to Simon or Theodore automatically. And it can do that because my boot operating system storage is on our Ceph storage, which is spread across our entire node and replicated 3 times, meaning that we can get to it from any node. It's fantastic. But if we go into HA and we go into groups, what we can do is we can create one. And what this is if you want to specify groups for where it uses a specific node first and then falls back to specific nodes after that, you can do that. So for example, if I have one called Alvin first, I can say I want to use all of the nodes, but the priority is going to be Alvin first and then use one of these 2 after the fact. And if you don't want it failing back after, so say Alvin fails, it goes to Simon or Theodore, then Alvin comes back up, but you want it to stay on Simon or Theodore, select this box, but I would want it to go back. So we're going to create that. And now I can go back into HA. I can click on here, edit, and assign this to Alvin first. Bada bing, bada boom. This is always going to run on Alvin first. Unless it's down, it's going to move to Simon or Theodore. And you can do this with whatever combination of nodes you'd like. Why are you saying this? So what we're going to do is we're going to stop this so it gets rid of that local CD drive ISO. I think what we're going to do is we're going to remove it from HA first because it doesn't seem to like that this exists, or it hasn't been officially removed from the configuration file yet because it's locked. Make sure you do this while the VM is off. Let's just say that. And it just migrated for some reason. That's pretty funny. Oh, I think I know why. So if we look at our group, we called Alvin first. So a higher priority means set it to that. So I have Simon and Theodore tied at 2, which means that Alvin was a lower priority, which is why our Docker VM just got moved. So how about we change that? Let's make this 2 and both of these tied for 1. And now change it. And based on that, our Docker VM should move back to Alvin. Yep, there it goes. Migrate. It's running. It's migrating. See how long it takes. 1, 2, 3, 4. 4 seconds, and it's back up and running just like that. I mean, that's pretty freaking cool. And that's the benefit of an HA Proxmox cluster. Now, was this the most efficient, best way of setting up a Proxmox cluster? Absolutely not. This was not a tutorial. This was me fumbling around and creating my only second real Proxmox cluster ever. It certainly wasn't the most efficient way to set up a Ceph cluster, but I think with Proxmox, they make it pretty easy to at least just get a basic setup running. And that's what I have here. So I will be evolving this over time. I do have another follow-up video planned where I go deeper into Ceph and learn, and hopefully teach you guys what I learn along the way. I'll be bringing in some of the folks from 45Drives. They're heavy into Ceph and know way more than I do about it, which isn't hard, honestly. But I'll be collaborating with them to hopefully teach you guys some pretty cool Ceph stuff. So stay tuned for that. But if you liked it, drop a like and subscribe if you want to go on that journey of highly available virtual machines, storage, and Ceph. But I want to give a huge shout out to my YouTube members and my Patreons. You guys are my highly available Proxmox cluster with 100 gig networking and like so many Ceph OSDs. You guys are the best. And if you're still watching, you're Kubernetes. Thank you so much, and I'll see you in the next one.